Welcome to another session on algorithms for VLSI design automation, and we are seeing some search algorithms. In the last session, I had explained about the depth first search. We'll see about the breadth first search now. Right? In the depth first search, as we said, we will follow a same path from the root node till the leaf node. In the breadth first search, it's a difference. All the nodes in a particular level will be seen. Right? I have taken the same graph, the same example as that of the depth first search here. Right? Okay. So, in the case of depth first search, the data structure which has been used, in the case of the depth first search, the data structure which has been used is a stack, right? A stack, if you find it difficult to remember what a stack is, consider a stack of plates. The plate which you keep at the last will be the one which will be taken out first. So it is a last in, first out. In the case of breadth first search, we will follow a queue type of approach. So it is a first in, first out approach. First in, first out data structure is being used here. Okay. So another thing which is to be mentioned is this is a graph. In most of the cases, they will say this is the source and this is the target. Here I have not specified anything, so I will traverse the complete graph. Right? I will only assume that this is the source. The target is not specified, and after completing the entire algorithm, I'll tell you if the target is something, where do I terminate my algorithm. Is that clear? One more thing to be mentioned is, consider S, the neighbors of consider A, the neighbors of A are B and S. In what order do I take them? For this, in A will specify a move gen. The move gen will tell you in what order the neighbors are to be taken. If you don't have a move gen, if a move gen is not specified, you make it a habit to take the nodes in an alphabetical order. Okay. So as we did in the previous case, we will take the help of open list and a closed list. Okay. An open list and a closed list. I'll start my algorithm with node A. Right. Initially, I have two lists which both are blank. I'll take A in the open list first, and at that time the node closed is empty. What do I do next? I shift this A to the closed list and find out what are the neighbors of A. The neighbors of A are, I'll take another pen so that it will be easy for you. Yeah, the neighbors of A are B and S. Right? So as I said, I'll take them in the alphabetical order, but since this is a breadth first search, I will include them after the present node. Okay. So B and S are taken, A is shifted to the next thing. So I'll put B and S here. The next step is I have to shift this B to the closed list. Where do I shift? In the case of depth first, I shifted it before the node. Now I'm not going to do it. I'll shift it after the node A. Why? Because in the case of BFS, it will be first in, first out. Right? So I have to give importance to seniority here. So B has been shifted here. So what are the neighbors of B? The neighbors of B has only one neighbor A, and that is in the closed list, so I don't have to worry about it. I have only one node here, S. Am I right? S alone is found here. So in the next step, I will shift A, B and S. S is shifted to the closed list. So now I should find out what are the neighbors of S. The neighbors of S are C, A, okay, and G. A is already in the closed list, so I need not take that again. I just have to take C and G. Okay. In the next step, I'll shift the leftmost node C here. Sorry. Yeah. A comma, B comma, S comma, C. So now I should find out what are the neighbors of C. What are the neighbors of C? The neighbors of C are D, E, F. D, E and F, and also S, but S is already in the list, so I have to add only D, E and F, right? So I'll put G here. I'll add D, E and F after G. Okay. Now I'll remove G and add it to the closed list. A comma, B comma, S comma, C comma, G. What do I do now? What are the nodes of G? The nodes of G are H, F and S. S is there in the list. F is there in the open list. I have to add only H. Where do I add H? H should be added after F. Okay. So it will be D comma, E comma, F comma, H. Okay. What's my next step? Shift D to the closed list. A comma, B comma, S comma, C comma, G comma, D, and I should add the neighbors of D to this list. What are the neighbors of D? D has only one neighbor, C. C is already in the list, so I don't have to worry about that. So my list will remain at E comma, F comma, H. What's my next step? E has to be shifted to the closed list. So A comma, B comma, S comma, C comma, G comma, D comma, E. Am I right? So what are the neighbors of E? The neighbors of E are C and H. H is already in there in the list. C is also there in the list. So my list, nothing is being added to my list. So my list remains at F comma H. What's the next step? F will be shifted to the closed list. So my list becomes A comma, B comma, S comma, G comma, D comma, E comma, F. Okay. So to find out what are the neighbors of F, the neighbors are C and G, right? They are in the list, so I don't have to worry about them. My list has become small now. It will be H. Okay. What's the next step? H will also be shifted there. A comma, B comma, S comma, G comma, D comma, E comma, F comma, H. Okay. And what about H? H, I'm sure it won't be having anything. H, one neighbor is E. It is in the list. G is also in the closed list. So both are present there. So my list has become an empty list. So if no source and target are specified, and if you are asked to verify any of the algorithms with this, you continue till your open list becomes empty. Okay. Now I have another suggestion for you. I've taken the same graph again and I specify that, I'll specify that my source is A and my target is E. This is something which I'm making now. Okay. So where do I stop my analysis? I should stop my analysis as soon as E goes to the closed list. So E has come here. So at this particular juncture, I should close my operation. Okay. So the path from A to E has been obtained here. Am I right? The path from A to E has been obtained here. So this is what I want to know. So what is the path now? A, B, S, C. So can we just go with that? A to B. Sorry. Yeah, I'll take this blue. A to B. Okay. and then what? B to S. A, so A to B, A to S, and then what? C and G. Okay, from S, C and G, and then what? D and E. Yeah, D, E, and then F is also explode, and finally H. So if you find out the difference, you can clearly see that the analysis goes in a breadth first manner here. A to B and S, S to C and G, C to D, E and F. So one level, all the nodes in particular level are analyzed, unlike the depth first search. In a depth first search, the operation goes from the root node to the leaf node. It follows a depth-wise pattern. Here, every node along a level are cleared till you reach the target. So with this, I complete my session. We'll meet in another session in the next class.